It began with a flicker in the data stream, a momentary glitch that shouldn't have been there. On September 12th, 2025, the James Webb Space Telescope, humanity's most advanced eye on the cosmos, halted its routine scan of a distant galaxy cluster. The interruption wasn't planned. It wasn't a calibration error or a software bug. It was an emergency override, a protocol so rare it had only been triggered twice in the telescope's operational history. The cause? A new dataset from the object designated 3I/ATLAS, the so-called comet that had already stirred unease among astronomers since its discovery weeks earlier. What poured in from Webb's instruments wasn't just unexpected, it was paralyzing. NASA's control room froze, not out of protocol, but out of sheer disbelief. The numbers didn't add up. The spectra didn't align. The object's behavior defied every model of natural celestial mechanics. This wasn't a comet. It wasn't even a question of what it was anymore. It was a question of what it was doing. And as the data unfolded, a chilling realization settled over the teams. 3I/ATLAS wasn't just passing through our solar system, it was interacting with it. The first anomaly came from the near-infrared spectrograph, NIRSPEC, which had been trained on 3I/ATLAS as it crossed 2.7 astronomical units from the Sun. Comets at this distance are typically sluggish, their icy surfaces barely warmed by the faint solar radiation. Outgassing, if it happens at all, should be minimal, a predictable mix of water vapor, carbon monoxide, and dust. But 3I/ATLAS was awake, violently so. Its coma, the glowing halo of gas and particles, was dominated by an overwhelming signal of molecular nitrogen, a compound so rare in cometary emissions that it's barely a footnote in most studies. The ratio was staggering, 12 parts nitrogen to 1 part water. For context, even the most nitrogen-rich comets, like 67P/Churyumov-Gerasimenko, studied by the Rosetta mission, never exceeded a ratio of 0.02. This was beyond anomalous. It was as if the object was exhaling a gas that no natural process could sustain at such concentrations. Stranger still, the coma was pristine, almost surgically clean. There was no dust, no rocky fragments, no chaotic scatter of debris, just a smooth, continuous stream of nitrogen, as if the object had been engineered to produce it. The data screamed one thing: this wasn't chemistry born of nature. This was chemistry with intent. As Webb's instruments dug deeper, the picture grew darker. The mid-infrared instrument, MIRI, detected something even more unsettling: a consistent emission of polycyclic aromatic hydrocarbons, or PAHs, complex organic molecules typically associated with star-forming regions or the remnants of ancient stellar explosions. But 3I/ATLAS wasn't near a star-forming region. It was drifting through the frigid void of our solar system, far from any nursery of stars. PAHs require intense energy to form, energy that shouldn't exist in the cold expanse where this object roamed. Yet there they were, their spectral signatures unmistakable, stacking across the 5 to 28 micron range with a clarity that left astronomers speechless. The concentration was high, too high, 10 to the 23rd molecules per cubic centimeter, a density that rivaled the richest molecular clouds in the galaxy. But what made the hairs on the back of every scientist's neck stand up wasn't just the presence of PAHs. It was their structure. The molecules weren't random. They showed a repeating pattern, a symmetry that hinted at a deliberate arrangement, like a chemical barcode etched into the object's emissions. No known comet, asteroid, or interstellar visitor, not even Oumuamua or Borisov, had ever displayed such a signature. It was as if 3I/ATLAS was carrying a message written in the language of organic chemistry. The anomalies didn't stop there. The object's motion was all wrong. At 2.7 astronomical units, 3I/ATLAS was accelerating, but not in the way comets do. Cometary acceleration comes from sublimation jets, gases bursting from the surface as solar heat vaporizes ice. But this object was too far from the sun for that. Solar radiation at that distance is a whisper, not enough to drive significant outgassing. Yet over 48 hours, 3I/ATLAS increased its velocity by 0.09 meters per second squared. For an object estimated to be 9 kilometers across, roughly the size of Manhattan, that kind of acceleration is staggering. It's the equivalent of a small mountain deciding to sprint. The data from the Pan-STARRS telescope network confirmed the change wasn't a fluke. The acceleration was punctuated by micro-oscillations, tiny bursts of speed that pulsed every 6.8 hours. These weren't random. They were rhythmic, precise, like the ticking of a cosmic clock. Models based on natural processes, solar wind, radiation pressure, even hypothetical internal fracturing, failed to explain it. The object was moving as if guided, not by gravity, but by something internal, something controlled. And then came the kicker. The acceleration wasn't pushing it toward the sun or out of the solar system. It was steering it toward a specific point, a narrow gravitational corridor near the orbit of Mercury. The trajectory data sent ripples of unease through the scientific community. When astronomers plotted 3I/ATLAS's path, it didn't follow the chaotic elliptical arcs typical, effectively, the path of a natural comet or asteroid shaped by gravity and momentum. Instead, it traced an eerily precise route, weaving between the gravitational fields of Jupiter, Mars, and the inner planets with a precision that defied natural mechanics. Using NASA's trajectory models for spacecraft, the path matched engineered flight patterns with a 94.3% accuracy, numbers unheard of for a natural object. The object wasn't just drifting, it was navigating, avoiding major gravitational wells with a finesse that suggested calculation. When projected forward, the trajectory pointed to a stable Lagrange point between Earth and Venus, a region known for its gravitational balance, but also for its low visibility from Earth-based telescopes. The implications were chilling. No natural object chooses such a path. No comet adjusts its course with such precision. The data suggested something far more unsettling. 3I/ATLAS was behaving like a probe, a machine with a destination. As the trajectory models raised more questions than answers, another dataset emerged that turned speculation into dread. The photometric data from the Hubble Space Telescope, cross-referenced with Webb's observations, revealed a periodic brightness variation in 3I/ATLAS. Every 6.8 hours, the object flared, a sharp spike in luminosity that lasted exactly 17 minutes before fading. This wasn't the irregular tumbling of a rocky body catching sunlight. The flares were too consistent, too mechanical. They didn't correlate with the object's rotation or solar exposure. Instead, they pulsed with a regularity that suggested an active process, an emission, a reflection, or something else entirely. Some proposed a highly reflective surface, perhaps a solar sail-like structure designed to harness light. Others speculated about an internal energy source, a reactor of some kind, but no theory fully explained the data. The flares weren't just bright, they were polarized, emitting light in a specific wavelength that matched the PAH signatures. It was as if the object was broadcasting its chemical code in light, a signal that could be read by anyone or anything with the right instruments. And the timing of the flares matched the micro-oscillations in its acceleration, as if the two were linked, parts of a single, incomprehensible system. The moment of truth came during a late-night analysis session at the European Space Agency's Control Center in Darmstadt. A team of spectroscopists working with Webb's data noticed something buried in the noise of the PAH emissions, a faint, repeating electromagnetic signal embedded in the infrared spectrum. It wasn't a radio wave or a broadcast in the traditional sense. It was subtler, a low-frequency modulation that pulsed in sync with the brightness flares. When the signal was extracted and sonified, converted into sound, it produced a haunting sequence of tones, a mathematical pattern based on prime numbers and fractal intervals. The pattern wasn't random. It bore a striking resemblance to the structural harmonics found in biological systems, like the folding patterns of proteins or the replication cycles of DNA. It wasn't a message in words or symbols. It was a blueprint, a chemical and mathematical framework encoded in the object's emissions. The team ran the data through every known model of natural phenomena: stellar winds, magnetic fields, quantum fluctuations. Nothing fit. The only remaining explanation was one no one wanted to voice. The signal was artificial, a product of design. And if it was designed, it implied a designer. The discovery of the signal triggered a cascade of reevaluations. Ground-based observatories, including the Very Large Telescope in Chile and the Keck Observatory in Hawaii, began detecting faint, synchronized anomalies in Earth's own magnetic field. Ultra-low-frequency pulses, spaced exactly 6.8 hours apart, were recorded in remote stations across Greenland, New Zealand, and the Atacama Desert. These pulses weren't caused by solar activity or terrestrial phenomena. They originated deep within the Earth's crust, in regions associated with ancient tectonic boundaries. The pulses matched the electromagnetic signature of 3I/ATLAS, down to the fractal harmonics. It was as if the Earth itself was responding to the object's presence, resonating with a frequency it recognized. Geologists were baffled. The Earth's magnetic field is shaped by its molten core, not by external objects. Yet the data was undeniable. Something about 3I/ATLAS was triggering a response, not just in our instruments, but in the planet itself. The implications were staggering. Either the Earth was reacting to a cosmic coincidence, or it had been primed to respond to this specific signal, perhaps long before humans walked its surface. The trajectory data took a darker turn when NASA's Deep Space Network conducted a radar sweep of 3I/ATLAS's last known position. The object had gone dark, its emissions fading to near undetectable levels, but the radar ping revealed something impossible. The return signal was distorted, not by distance or interference, but by a deliberate modulation. The echo came back 0.19 seconds too early, carrying a layered pattern that matched the fractal harmonics of the infrared signal. The distortion wasn't random. It was structured, repeating in cycles that aligned with the object's brightness flares. When the data was cross-referenced with historical records, a chilling connection emerged. Similar distortions had been detected during the passage of Oumuamua in 2017, faint and dismissed as noise at the time. But the patterns were nearly identical, suggesting a continuity, a recurrence. 3I/ATLAS wasn't a singular event. It was part of a sequence, a series of objects or signals that had been passing through our solar system, unnoticed or misunderstood, for decades, perhaps centuries. As the scientific community grappled with these findings, a new observation from the Webb Telescope added fuel to the fire. The telescope's deep field imaging, intended to study distant galaxies, began detecting faint, rhythmic fluctuations in the interstellar medium. These weren't stellar phenomena or cosmic background radiation. They were localized, confined to a narrow corridor of space that aligned perfectly with 3I/ATLAS's trajectory. The fluctuations pulsed in sets of 5, spaced 6.8 hours apart, mirroring the object's light curve. When mapped, the fluctuations formed a pattern that extended beyond our solar system, stretching toward the outer reaches of the Oort cloud. The data suggested a network, a series of invisible relays or markers that 3I/ATLAS was either activating or following. The idea was almost too much to process, an interstellar infrastructure hidden in plain sight that our most advanced telescopes were only now beginning to detect. The object wasn't just a visitor, it was a key, unlocking or calibrating something vast and ancient. The final blow came when a team at Caltech, using machine learning to analyze the combined spectroscopic and trajectory data, uncovered a hidden structure in the emissions. The nitrogen and PAH patterns, when plotted over time, formed a three-dimensional lattice, a geometric framework that resembled the molecular scaffolding of prebiotic chemistry. It wasn't a living organism, but it was something eerily close, a template, a chemical precursor that could, in theory, catalyze the formation of complex organic molecules. The lattice wasn't random. It followed a recursive algorithm, a self-replicating pattern that echoed the earliest stages of life on Earth. The implications were profound. If 3I/ATLAS was releasing this lattice, it could be seeding the solar system with the building blocks of life or something else entirely. The lattice's structure was too precise, too optimized to be a natural byproduct. It suggested a purpose, a design, a plan. And if Earth's ancient rocks contain traces of similar chemical signatures, as some paleochemists now suspect, then 3I/ATLAS might not be a new arrival. It might be a return. The sudden silence of 3I/ATLAS only deepened the mystery. Just as it approached 2.5 astronomical units from the Sun, its emissions, nitrogen, PAHS, electromagnetic pulses, dropped below detection thresholds. The brightness flares ceased. The acceleration stabilized. The object didn't disappear. It went dormant, blending into the cosmic background like a predator lying in wait. Every major telescope, Webb, Hubble, the VLT Subaru, confirmed the shutdown. It wasn't a natural fade. It was abrupt, coordinated, as if the object had completed a task and powered down. The radar pings continued to return distorted signals, but they grew fainter, as if 3I/ATLAS was masking itself. The trajectory models, however, showed a subtle shift. The object was no longer heading for the Lagrange point. It had adjusted its course again, this time toward a region of space known as the Earth-Sun L2 point, a stable gravitational zone where several of NASA's satellites operate. The region is notoriously difficult to monitor, a blind spot in our observational network. If 3I/ATLAS was heading there, it wasn't leaving, it was hiding. The global scientific community was left reeling. The data was too consistent, too precise to dismiss as natural. The nitrogen emissions, the PAH structures, the electromagnetic pulses, the navigational precision, all pointed to something engineered. But by whom? And for what? The most conservative theories suggested a natural object with unprecedented chemistry, perhaps a remnant of an ancient stellar event. But even these theories strained credulity. The lattice patterns, the fractal signals, the Earth's magnetic resonance, they didn't fit any known natural process. The more radical theories whispered in closed-door meetings proposed something far more unsettling. 3I/ATLAS was a probe, a relic, or a beacon, part of a system that predates human civilization. Its purpose wasn't to communicate, but to execute a task, a calibration, a test. The Earth's response suggested it wasn't the first time. The lunar echoes, the magnetic pulses, the chemical echoes in ancient rocks, all hinted at a history we've yet to uncover. As the telescopes resumed their normal operations, the questions lingered. The faint interstellar fluctuations continued, pulsing in the background, unnoticed until now. The Earth's magnetic anomalies persisted, faint but rhythmic, like a heartbeat from the deep past. The distorted radar pings from the L2 point grew weaker, but they didn't stop. 3I/ATLAS was still there, silent but present, a shadow in the data. The scientific community is now racing to reanalyze decades of observations, searching for signs of earlier visitors, earlier signals. The possibility that Oumuamua, Borisov, and now 3I/ATLAS are part of a larger pattern can no longer be ignored. The data suggests a network, a purpose, a presence that has been watching, waiting, or perhaps preparing. The question isn't whether 3I/ATLAS is natural or artificial. The question is what it activated and what comes next. We stand at the edge of a discovery that could rewrite our place in the cosmos. The James Webb Space Telescope didn't just capture data. It caught a glimpse of something that doesn't belong, something that moves with purpose, emits with precision, and resonates with our planet in ways we can't explain. The silence of 3I/ATLAS isn't the end. It's a pause, a moment of stillness before the next phase. The signals are still out there, pulsing in the dark, echoing in the Earth's core, whispering in the interstellar void. We thought we were the observers, the hunters of cosmic truths. But what if we're the observed? What if 3I/ATLAS wasn't here to find us, but to remind something else that we're here? Subscribe to stay ahead of the next signal, because the universe isn't silent anymore. Share this story with someone who questions what's out there. And tell us in the comments, Do you think 3I/ATLAS is a relic of a forgotten past or the harbinger of a future we're not ready for? The data is clear. The answers are not.